G'day folks, I've been asked to explain some work from the Cambridge Preliminary Maths Extension 1 Exercise 5D. So specifically what I've been asked to do is to look at how we add, subtract and multiply ordinates. Okay, so the first part of the question, or the question was actually in the textbook rather, asked us to add the ordinate, so get y equals f of x plus g of x, where f of x was x to the power of 4. Now, we've seen this graph before. X to the power of 4 is basically just a steeper version, if you like, of the parabola y equals x squared. Steeper on the sides and flatter on the bottom. Okay, so for values between -1 and 1, if we zoom in there, so for values between -1 and 1, y equals x to the power of 4 is a lot flatter than y equals x squared. I'll just show you y equals x squared. So you can see that y equals x squared is that darker maroon colour there. You can see that it is steeper inside between -1 and 1, and y equals x to the power of 4 is flatter between -1 and 1. But outside those bounds, y equals x to the power of 4, that lighter line is much steeper. So if we zoom out, hang on a second, if we zoom out, we see that y equals x to the power of 4, that inner graph is much steeper, okay? And the y equals x squared is much flatter. Let's get rid of the x squared so we don't confuse things. There's the graph of y equals x to the power of 4, or f of x for the purpose of our question. We wanted to be able to add the ordinates. Now, ordinates is just a fancy term for the y values. So the y value here, for example, is 2, the y value here is 4, y value here is 6, for varying values of x. We want to be able to add the ordinates of that graph to the ordinates of g of x. Now, g of x is this blue curve here. Okay, if we have a look at this, if we expand these brackets out, we're going to get negative x squared plus 2x. So the negative x squared tells us that the x squared tells us we've got a parabola. The negative x squared tells us that it's a sad parabola, okay? So it's concave down. The x minus 2 tells us that at x equals 2, we're going to have a root. So the curve is going to interact with the x-axis there. It's going to cut the x-axis. And over here, at x equals 0, we're going to have another root. So if I put 0 in there, that's going to be 0. If I put 2 in there, that's going to be 0. So that's where my zeros are, at 0 and at 2. Okay, so they're the graphs of f of x plus g of x. Now, I had a go on the board behind me. I rubbed it off because for as neatly as I tried to draw these, I just couldn't. I just couldn't get my curves interacting properly, especially showing things like the flatness of x to the power of 4 in there, and a neat interaction with that maximum turning point there, and especially to get, where the y values of the two curves were the same. So have a look here. X equals 2. So let me zoom in just a tiny bit. Oop, show me there. Come on, zoom in. Okay, so at x equals -1, f of x has got a y value of 1, or an ordinate of 1. At x equals -1, g of x has got an ordinate of -3. Okay, now we want to find out where these guys actually have the same, or at least the absolute value of the ordinates is the same, because that's going to be a turning point, if you like, on our curve. So let's use the software here to see if we can see where that's going to happen. It seems to me that somewhere here, close to 2, we go from a y value of 4 there, a y value of -4 there, very close, but this is, it's not for the same x value. So somewhere between, let me zoom in a bit further, somewhere between -2 and say -2.8 or 2.6 or thereabouts, we're going to have our curves turning around. It was just pure and simply too hard for me to get that kind of accuracy when I was just drawing it freehand on the board. So I escaped and came here to Desmos. What we're trying to do though, is we're trying to look and say, well, these y values here plus these y values here are going to give me what exactly? Let me zoom out a long way and show you something here. So zooming out a long way. Now for this x value here, whatever this x value here is, so if that's 20, that'd be 5. For x equals 5, f of x is going to be huge. It's going to be way up here at 625. Okay, so I mean, yeah, look, take my word for it. You can get x equals 5 to the power of 4. Whoops, let me get out of that. Don't know why it's doing that. It's going to be way up there at 5 to the power of 4 at 625. Whereas this guy here for x equals 5 is only going to be down here, and we can work it out exactly. That's 5 take away 2 is -7 times 5 is -35. Okay, so we're down around there. I've actually zoomed out too far. X equals 5. No, what have I done there? Oh, sorry, that'd be 3. So that'd be -15. So x equals 5, we're down here at -15. But at x equals 5 here, we're up at 625. So the y values here are much bigger than the y values here. So when we add these two graphs together, for these values of x, the curve is going to be up here. It's going to be positive. It's going to be way up here. Okay. Over here, when we add these x values together, these x values are massive compared to these, these y values, right? These y values are massive compared to the y values over here. So when we add y values out here, our curve is going to be very, very high. The difficulty comes in what happens around here, where the curves interact. What happens? Well, look, when I add the blue curve, x equals at x equals 1, y equals 1, to the red curve when x equals 1, y equals 1, I'm going to be up here at 2. So I've got a certain point there that I'm going to pass through. I'm going to be passing through the point 1, 2. What else do I know? Well, over here I've got the red curve is on 0, the blue curve is on 0. When I add them, I'm going to be on 0. So I know, I mean, there are some things I know. If I just very, very carefully take that height there and add it onto the top of that height there, and add that little tiny bit there onto it, and if I keep on doing that, I'm going to end up with a whole sort of string of points that shows this this sort of increasing nature. But then a weird thing happens around here. I'm still positive, and I'm adding to something that's increasingly positive, but then over here, I'm not adding anymore. Now I'm subtracting. I'm taking away these little negative amounts. So something changes around x equals 2 on the where the curves are added. Let's have a look. Okay, so we're going to cheat and use Desmos to just add all those points and then just draw a graph through them, and that's what it ends up looking like. Okay, so down here at x equals -1, we end up with a minimum value. At x equals -1, we end up with a minimum value of 2 for our two functions. And then because the red curve starts to grow much, much faster than the blue curve decreases, well then our curve turns around. Okay, we're going to end up at 0, where the Desmos will tell me that's at -1.521. That's the point where our y value on our red curve, is the absolute value of that at least is the same as the y value on our blue curve. Okay, they add out and they cancel out at 0. But let's zoom out a little bit. You've seen what each graph individually looks like. Let me remove f of x and g of x. We'll just look at the sum. Okay, so that's what it looks like there. You can see that curves were being added. After we got to 1, we started to increase the rate, and after we get to 2, let's just pan up a little bit. It's imperceptible on the graph here, but the curve actually has a very, very, very slight increase in the rate that a decrease in the rate that it's changing. But eventually, x to the power of 4 so overwhelms that it pretty much takes over. Okay, so that's what our f of x plus g of x looks like. Okay, very difficult, very, very difficult to just freehand accurately sketch that. You really do need software to get that, or you need a little bit, well, not a little bit. You need a fair bit of calculus that we haven't started yet in our course. What about the sum of f of x? Sorry, the difference of f of x and g of x. What if we were to get our red curve and subtract the blue curve? Well, look at this. Here the blue curve is negative. Right? The blue curve is negative. So if I was to get the red and subtract the negative, well, to subtract the negative is to add. So this half of my curve is actually going to rise even quicker than the red curve is rising. Okay, it's going to rise even quicker. Just pausing here. Come in, miss. Hi. Never mind. Okay, folks. Sorry for that interruption. We're back now. So we're going to look at. We were looking at getting the red curve and subtracting the blue curve. Well, look over here. The red curve is lower than the blue curve. The blue curve is greater than. So when I get the red curve and subtract the blue curve, I'm actually going to come underneath the x-axis. Over here where the red curve and blue curve, let me zoom in there. Over here where the red curve and blue curve are equal, when I subtract them, I get 0. Over here when the blue curve is bigger, I'm going to be coming underneath and then back around to here. So we're going to have a 0 here and a 0 here. Well, then what happens? Well, then the red curve grows much faster than the blue curve. So red minus blue is going to be positive, and it's going to be positive all the way. Okay, so let's have a look at what that looks like. And we see exactly what I just said. So over here on the left-hand side of the 0, with the red curve minus the negative, so it's plus the blue, increases much quicker than y equals x to the power of 4. That's why it's above it there. Over here between 0 and 1, where the red curve is lower, we end up being underneath the x-axis. And then after x equals 1, where the red curve is much bigger than the blue, our purple curve is much higher. Okay, oh sorry, not higher, much higher, is increasing. Okay, and eventually x to the power of 4 increases so quickly that it's indistinguishable from our new curve. Okay, so let me just get the other curves out of the way, and that's what we look like there. There is ever so slight changes in the curvature there, again, that we need calculus to study in any sort of detail. So for purposes of our course, just the discussion we did on looking at y values and how they add or subtract is more than enough. Okay, what about the product of the curves? Well, what happens then? Well, when we're looking at products of curves, we're basically looking at, are we getting positives and positives, or negatives and multiplying them, and then what happens? Look here, to the left of 0, when x is less than 0, I've got a positive multiplied by a negative. It's going to give me a negative. Okay, between 0 and 2, I've got a positive multiplied by a positive. It's going to give me a positive. Over here to the right of 2, so when x is larger than 2, I've got positive values on the red curve, negative values on the blue curve. It's going to be a negative. So the product of these curves is going to be negative over here, positive in here, and negative out here. Over here I've got very, very small numbers times these numbers, which will give me small numbers. over here I've got very, very small numbers times very, very big numbers. But they're going to end up, it's going to end up being 0. Over here I've got 0 times whatever that is. So here y equals 0. Well, 0 times whatever is going to give me 0. So let's have a look at what the product looks like. We'll get Desmos to do the hard work for us. I will zoom out just a tiny bit. Oopsie days, that's not working. Okay, so large positives are up here times positives there give me large-ish numbers, goes up to just over 4. But then when the blue curve hits 0, it doesn't matter how big the red curve is, we're going to be at 0. And then we've got negative values here, multiplied by very big positive values there, brings our curve down into the negative. Okay, here we had a horizontal inflection. Okay, horizontal inflection. So we need a little bit of calculus to be able to study that in detail. So really that's the most we can say without getting into the calculus. I think that's the most we can say about the products of the functions there. I hope that helps. The principles at play when we're adding or subtracting or multiplying ordinates is to look at the y values of one, the y values of the other, and just add them together. That's all we're looking at. Okay, and if it's meant to be done from a curve, then they're basically after seeing that you understand the basic ideas that positives and positives add to positives, that big positives and tiny little negatives still add to positives. Okay, big positives and not so big negatives add to positives. It's those general ideas they're after. They're not after specifics. If they were, it'll be a calculus question. We'll be differentiating. We'll be finding stationary points. We'll be getting the second derivative and studying concavity and things like that. That's beyond the scope of exercise 5D. I hope that helps.